Good evening, Major Vandrish. This is C3C Conley Walters, and today I will be talking about arguably the most interesting and fascinating animal on planet Earth. I know that you have mentioned your favorite animal, but I think after this presentation, you might be a little bit more of a fan of the platypus, which more scientifically is known as Ornithorhynchus anatinus. This creature, the platypus, I find it absolutely fascinating due to many adaptations and characteristics that it has. It is a relatively small aquatic mammal. It's only about 1 to 2 kilograms, and it lives relatively exclusively in eastern Australia and Tasmania. It's found in fresh bodies of water, so rivers and lakes in that area. Before getting to the adaptation I wanted to focus on mostly today, I did just want to talk a little bit about why this animal interests me so much, why I did my presentation on it. The platypus is one of the only egg-laying mammals, which is fascinating. It has a bill with complex electroreceptors. These electroreceptors allow it to pick up electrical signals as impulses underneath water, which assists it in finding food, being a carnivore. It finds prey underneath the water in the riverbed. It also, being a mammal, it does produce milk. However, unlike any other mammal, it excretes its milk through its skin, much like it's sweating, which I think that's awesome. Being largely aquatic, however, I did want to focus on what makes the platypus such an efficient swimmer. Some of these, and not to name all of them, but some of these adaptations it has, it's that it has dense waterproof fur, it has webbed feet and limbs, it has a broad flat tail, a streamlined body shape, and what I wanted to focus on the most is this, as it utilizes an alternating forefoot rowing motion. To go in a little more detail about that, this rowing motion is unlike many other semi-aquatic animals. Most utilize a vertical hindfoot paddling technique, much like this river otter here. As you can see, it's utilizing its hind feet to paddle, much like a duck would or a beaver, even muskrats and ferrets when they enter water. However, a platypus, as you can see here, it utilizes its forefeet. Its flippers in the front being webbed function much like the paddles of a canoe or a kayak to alternate, and as they alternate, they're able to provide forward propulsion. And really, the benefit of this is that it's much more efficient than the hind foot paddling technique. The hindfoot paddling technique has high energy expenditure. It's very inefficient in its use of motion. Animals lose a lot of, they can't take much advantage of the surface area of their flippers or their fins or their feet because they're unable to really position themselves to gain the most effective forward propulsion. And it's really ineffective when these animals are trying to submerge just because of the paddling and the forward propulsion. They're not able to stay underwater for very long, or if they do, it's relatively ineffective in when we're talking about energy usage. And so, studying animals with a scientist with a very, I thought it was a very fitting name, Mr. Fish in Pennsylvania, he wanted to study and be able to compare this energy expenditure due to the rowing technique versus the paddling technique for platypuses and be able to compare that to the same technique of other animals. So what he did, he calculated a cost of transport, which is a unitless value. It's simply used for comparison. And how he did this in an experiment where he used a water flume, which is kind of like one of those resistant swimming pools, one of those infinity pools. He used six platypuses, and in these, at a respiration chamber, they were able to calculate the metabolic rate at various velocities for these platypuses. And using this, as well as the stroke frequency, or how often they were paddling or stroking per second at certain velocities, they were really able to calculate this cost of transport. And they use this cost of transport to compare it to various other animals, as we can see in this diagram, which is really the results and the conclusion of their study. So to understand this diagram a little better, we can see that they're comparing the platypus to, for example, minks and humans and muskrats and uh, other animals, kind of more towards the bottom of the list, relatively successful and efficient aquatic species. And we can see these filled in circles, or in this case, a triangle. The filled in ones versus the hollow ones, the filled in represent those species that were utilizing the paddling technique at the surface of the water. And then the The hollow ones, so the empty ones, these are species that were utilizing a submerged sort of a submerged form of propulsion. As we can see, the cost of transport being on the y-axis and the mass being on the x-axis, they were able to compare, even with differences in masses and differences in maybe metabolic rates, they were able to succinctly compare different species. And what their largest conclusion, what they came to find out, was that due to the swimming technique, the rowing versus the paddling, the platypus is energetically more similar to highly derived aquatic species than to hindfoot paddling semi-aquatic mammals. So as you can see in this diagram, the platypus, when compared to animals and species of relatively the same mass, in this case a mink and a muskrat, it was far more energy efficient. Its cost of transport was significantly less than those of those species. If you were to look at the scale on the y-axis, you can see that the platypus runs in at about point around zero point 0.7, zero point 0.5 to zero point 0.7 ish, and we can see that the muskrat is somewhere around 2, and then even the mink comes in almost at 7 or 8, which is very impressive to see that simply because of an adaptation in the way that this species paddles and the way that it propels itself forward using a rowing motion with its front flippers versus a paddling motion with its hind flippers, it is able to be far more energy effective and therefore uh, using survival of the fittest, it is far more fit for its environment, isn't able to has an advantage over its competitors in this environment. I hope that because of this presentation, Major Vandris, you find the platypus a little more interesting, just like I do, and that you're able to appreciate its fantastic adaptations. Thank you.